Hi guys, so let's get started guys. Okay, so today's session is Docker tutorial. So guys, I will start with very basics why Docker is required. So guys, why Docker is required? First of all, we have to understand the importance of the Docker. So for example guys, I take an example, we have multiple environments are there in our project. Dev environment is there, QA is there, pre-prod is there, and prod environment is there. Okay, so if you would have noticed, our code works fine into the dev environment, and for other environments might work, might not work. For example, till QA environment our code works, dev and QA it works, but when it goes to pre-prod and prod environment, it sometimes doesn't work. So let me put some more placeholders here. Like in all the environments, we have two things are there which is common. The common thing is your installation layer, okay, and your configuration layer. Okay, so these both layers are common across all the environments. What changes here is these two elements are common everywhere. What changes here is your deployment layer. Your deployment layer. So if you observed here, when you deploy your components, okay, after deploying your components, your code works fine into the dev and QA environment, or probably the lower environments. When your code moves into the higher environment, when your code moves to the higher environment, it doesn't work. Okay, it doesn't work. Different configurations, different versions which are being installed, right? These are couple of reasons are there. Okay, and this is guys, a problem is there, different dependencies, different problems are there. So what is the solution to the problem is, if let's say if I'll develop a mechanism where while deploying the components, instead of deploying a deployable components, if I will club all the three dependencies layer, okay, whether it's a deployment layer, configuration layer, or installation layer, as a one guy. Okay, if somewhere I will develop a mechanism wherein I'm deploying them as a one guy or one person. Okay, now you can see I'm deploying them as a one guy. I bundled all the dependencies and then I'm deploying. Do you think this problem can be solved? Because I'm now deploying a package wherein installation layer is there, configuration layer is there, deployment layer is there, right? 80% problems can be solved. So the approach guys which allows you to bundle your dependencies, okay, that approach we are calling it in the industry as a containers, which contains your dependencies. We are calling this approach as a containers. How many type of containers are there in the market? So Docker is one of the container, RKT is one of the container, okay, LXC is one of the containers, multiple containers are there, okay, but these three are most important containers. And out of these containers, this container is the most famous container which is widely used in market. So Docker, Rocket, and LXC is the container. So Docker is the most important container in the market. Now good, we came to know one reason, that because of having environment dependencies, we want to simulate the environment. One environment should be equivalent to the another environment. Okay, that is the reason we are using containers. But we have to understand what is the difference between containers and the virtual machine. Okay, so what is the difference between a container and a virtual machine? So let's talk here. Let's say what is there in the virtual machine. First, for any virtual machine, we have hardware is there, On top of that, we will have operating system is there. Okay. On top of that, we will have a hypervisor is there. On top of that, we will have virtual machines are there. VM1s are there, VM2 is there, VM3 is there. Okay, and these both flavors are operating systems. Okay, so this is the typical architecture of a virtual machine. Now, when I talk about the containers, okay, how container works is this two layers will be same everywhere. On top of that, instead of hypervisor, so guys, hypervisor is a technique or a tool which helps to create virtual machine, which helps to virtualize your hardware. Okay, on top of that, you can create a virtual machine. Now, equivalent to the hypervisor in container world, we can think of Docker engine. What Docker engine does is Docker engine creates an environment wherein you can start multiple containers. So instead of 3 virtual machines here, you will have your containers would be there. Okay, C1 is your container, C2 is your container, C3 is your containers. Now guys, when we will differentiate, only the difference which comes here is hypervisor instead of hypervisor, we have a Docker engine layer is there. But what are the actual differences are there between virtual machines and the containers are, for example, when you go to a virtual machine, we will do some calculations, some statistics we will do. Okay. So guys, what do you think? How much time a virtual machine will take to start? What is the boot up time of a virtual machine? Okay, on an average, I will take 2 minutes is the boot up time of a virtual machine. Now next guys, how much memory is required to start a virtual machine? How much GB of RAM is required? Maybe 3 GB. Okay, so let's say VM1 is consuming 3 GB of RAM and its app is consuming 2 GB of RAM. Let's say VM2 again 3 GB of RAM it takes to start, but app is consuming 1 GB of RAM. VM3 is consuming, let's say 3 GB of RAM to start, but app is consuming, let's say 1.5 GB of RAM. Okay. Now VM to start, I need 9 GB of RAM, and app to start, I need 4.5 GB of RAM. So guys, do you see how much is the overhead here to start 4.5 GB of RAM application? 9 GB is the overhead. So you want to start 4.5 GB RAM application, but for that you need 9 GB of overhead. Okay, and to start a virtual machine, we need 2 minutes of time. Okay, leave application. To just start a virtual machine, I need 2 minutes of time. Now let's compare this stats with the container. So when I compare these figures with the containers, guys, so container startup time is, can anyone tell me what is the container startup time would be? How much time a container takes to start? 20 second. Okay, so ideally guys, if you see the container books, they claim that a plain vanilla container takes 1/20th of the second, which is a single millisecond, right? And containers guys doesn't take any memory to start, or if it takes, it's a negligible memory, probably in MBs. Okay, it takes negligible memory to start. Okay, so guys, with the containers, how much memory you have saved in the same example? 9 GB of memory, right? So isn't it guys, container is far better solution than virtual machines. But guys, some places are there okay, wherein container has its own utility, virtual machine has its own utility, right? So does it mean, guys, containers will be eventually replacing virtual machines, or it has replaced already virtual machines? So guys, it's replacing gradually. Okay, I mean, legacy application should run on virtual machines only, because containers are always lightweight. Okay, containers are not heavyweight. So virtual machines cannot be never removed from market. But yes, nowadays if you see, trend is more to move on to the containers. So guys, here you can see what we are going to learn in this session is what is Docker. We have just explained, okay, and why we need Docker. We have just explained to you, and then we'll cover Docker example, case studies, Docker components, hands-on. All these things we'll be covering. We understand, like like with the help of Docker, you can solve your problems of having multiple environments. Virtual machine sometimes doesn't work. I mean, they have a overhead is there. That's why we have to go to containers. And the problem is, something is working on the lower environment but it doesn't work on the higher environment. We have discussed that part. To only the simulate to the environment is we should deploy everything as a package. Okay, so this is again, problems can be solved using containers. So you can see here, your containers has a Docker engine is there. On top of that, your bundles libraries are there, which forms a container. So you can see here, on top of virtual machines, we have a host operating system is there. We have a hypervisor is there. On top of that, we have guest operating systems are there. Libraries, apps are there. So this is nothing but a virtual machine. So what is the advantage of virtual machine? Multiple OS in the same machine. Easy maintenance and recovery, lower total cost of ownership. Ownership as in maintenance cost. Disadvantage is multiple VM leads to unstable performance. Suppose, guys, this guy is not available because of any reason, so it actually creates uncertainty for n number of virtual machine. Hypervisors are not efficient as host operating system. So guys, hypervisor is just a temporary solution, okay, and that is sometime unstable solution also. Long boot processes, so approx 1 minute they have given, but actually it's 2 to 3 minutes sometime. So containerizations, container on same OS kernel, lighter and smaller. So guys, there is a term is there, virtualization. So what virtual machines virtualize is, they virtualize the hardware. Hardware resources are going to be virtualized with the help of hypervisor. When it comes to the container, the base operating system resources are going to virtualize, and what is going to virtualize is kernel is going to virtualize. If you have n number of containers are there, each and every container is sharing the same kernel, okay, and boot up time is around 1/20th of the second. Now there is a calculation is there, like when container is good, when VMs are good. So guys, when you have bulky application is there, legacy applications are there, go with the virtual machines. When you want slow speed, your application wants more boot up time, go with this guy. So this is the slow guy. When you want lighter applications, when you want fast speed, go with the containers. So this calculation we have just done in case of virtual machines. You have some memories being used for virtual machine own purposes, okay, and few things are there for your application purposes. So you can see here, total 16 GB memory is used, and 7 GB memory is used just only to start your VMs. It could have been used for your application startup also. You can see here 9 GB is being used to start your application, but there is no overhead is there to start your containers. If there is a overhead, it's minimal, very minimal. So in case of virtual machines, you have multiple OSs there, separate libraries are there. In case of Docker, it's the same operating system, separate libraries are there. It's a lightweight, it's heavy. Okay. So which is the operating system level virtualization, guys? Docker is the operating system virtualization. So guys, now I'll tell you what is the architecture of the Docker. So guys, in Docker engine, when you install, Docker engine has two parts into it. Okay. One part is the Docker client, and one part is Docker server. Okay, and both are the part of Docker engine. How it works is, guys, whenever you fire a command from the client, that command will be honored by Docker server. So this Docker server is nothing but, guys, you can call it as a Docker daemon also. Okay, Docker daemon also. Okay, this is nothing but a processor. So any virtual machine, if you go and see, okay, Docker engine means it is a combination of a client and a server. If you want to see the architecture, you can see on the Google. I'll show you Docker client server architecture. Okay, so you can see in this diagram. Okay, so client and server both are a part of the same guy, which is Docker engine. From CLI, you are firing a command which is being honored by your Docker daemon. So basically, Docker daemon, from you are invoking some REST API in the form of command line argument, and whatever command you are firing, that will be honored by your Docker daemon. Same way here in this my diagram. Okay, Docker engine has a client and a server. If you're firing anything, that will be honored by Docker daemon. Now there is a confusion is there. What is what? Like, what is the Docker file? What is the Docker? What is a Docker file? What is a Docker image? What is a Docker container? Okay, so there is a term is there called Docker file. Then you have a term is there called Docker image, and then you have third is there called containers. What is the difference between class and object? Class is a blueprint and object is an instance, right? Can we have multiple instances of a class? What is required to get a class? Is it a Java file, .java file? So if I'll tell you the correct flow, first a Java file has to be created. With that, your class has to be created, and with the class you have to create your instance, right? Which is the active entity, which is the passive entity out of class and object? Object is a active entity and class is a static entity. So guys, you can see this diagram. So your Docker file is nothing but a Java file kind of, who actually keeps the code of your container, which is written in the Go language. Okay, and then it converts your Docker file into a binary file which is called Docker image, and with Docker image it converts into multiple containers. So you can assume that your class is an image and your instance is a container. Okay, class is a static guy, container is a active guy. Okay, where these images will be stored by default? So guys, these images will be stored by default in the repository called Docker Hub. Okay, this is a public repository. You can store them in the private repository also. Like Docker have its own private repositories there. Nexus, one of the repositories there. JFrog. Okay, AWS ECR is also there, and Azure Docker repo is also there. Okay, so multiple repositories are there which can be your private repositories. So this guy is a private wherein you can store your images. Okay, you can store them publicly also, which is public repository. So when you go to the Docker Hub, against each image they are sharing their source code, which is the form of the Docker file, into GitHub. Okay, so this guy is stored in the GitHub by default, but you can keep it in your own version control system also. For example, if I'll go to my hub.docker.com, this is my own repository is there, wherein I've created my own namespace. Okay, Manoj 3004 is my own namespace which I have created. Inside that, if I will go and search here Jenkins, so guys, Jenkins image is there. So guys, always remember, if there is no prefix, there is no namespace, that image is being owned by Docker company. If there is a prefix is there, it means that image is owned by another particular guy. And if you go with the image which is being shared by Docker company, definitely they would have shared their source code also, or Docker file also. If you go here, they have two versions are there, 2.6.3 and 2.6.3 Alpine. If you click on this guy Docker file, it will take you to the GitHub. Okay, and in the GitHub you can see their source file is mentioned, Docker file is mentioned. Okay, so if I'll compare with my flow, we went to Docker image for Docker Hub. In the Docker Hub, public images are mentioned without any prefix. If let's say I am sharing my image, I can share it under my namespace like Manoj3004 and the image name. And if you go to a public image which is shared by Docker Hub, okay, Docker company, for that the source file, the Docker file is being stored into the GitHub. Okay, we have just seen it is stored into the GitHub. Okay, if I'll go to my own image or my own namespace, okay, let's say hub.docker.com. So you can see here under my namespace multiple images are there. Manoj3004, hello world, like that multiple images are there. If you don't have your own namespace in this product, it will not allow you to push any of the image. Yeah, so let's go into another flow diagram. So guys, how it works is, when you pull or push the images is, from the client you are firing a command. Okay, let's say client is there, you're firing a command. Okay, probably I'll go to this guy. Yeah, from the client you are firing the command and Docker daemon is serving the command. Let's say you are firing a command that you want to pull an image. So what happens is, okay, Docker daemon has a reference to Docker Hub. Okay, so we call it as a registry also, guys. So basically what happens is, in Docker Hub, the service which is responsible to store the images, we are calling it as a registry. So if you read the books of Docker, they are calling Docker Hub as a Docker registry. So when you're following a command, when you are firing a command from Docker to pull an image, what Docker daemon will do is, it will go to the Docker Hub, it will pull the image, and then it'll keep into the machine wherein Docker daemon is there. Okay, let's say this is the image is there, and then it will be keeping over here. Now when you are firing a command like I want to run an image or I want to convert it into a container, so what it will do is Docker server or Docker daemon, it converts your image into your container. Okay, it converts it into a container. Now we will see like how it works. So guys, whenever we learn any of the technology, which is the first program is there that we use it. Hello world, right? Hello world. So guys, if I want to check whether Docker engine is there, I can fire a command Docker version. You can see it here. Docker version has two parts into a client version and a server version. Okay. Now, when you want to see how many images I have, so I have a command is there called Docker images. It tells how many images are there. So I have already a hello world image. So I can delete this image with the command Docker RMI hello world. Okay. So it has deleted that image. So guys, to list the images, command is Docker images is a command. To remove an image, the command is Docker RMI. This is the command. Okay. Now what I'll do is I will go and type the command here Docker PS. So PS, what it will do is it will list all the containers which are running in my system. If I will run here Docker PS -a, it will list all the containers which are even there in my system as a existed state. Okay. If you want to remove any of the container, you can type a command Docker RM and the container name. So let me remove my all the exited containers. If containers are not getting removed automatically, you can forcibly remove them. Okay, so these are removed. If I'll type here command Docker PS-a, you'll see few containers are there. Let me remove them one by one. Okay, so these are being removed. Okay, so Docker if you type, I don't have any of the running containers. Okay, so if I'll type here Docker images, I have certain images are there, but hello world image is not there. So at the moment I'm more worried about hello world image. So I can type a command here, Docker pull hello world. So what it will be doing is it will be pulling this hello world image from Docker Hub, because by default Docker Hub references are there here. You can see here it has actually pulled my image. Now if I have to run this image, I can type a command docker run hello world. Okay, so guys, whenever we run the hello world program in java.net, what it does, it just print the hello world and exit it, right? So this hello world container also will print the hello world container and then it will be exited. Okay, you can see here hello from Docker, it is printed hello from Docker. And then if I'll type the command here docker ps-a, you will see this container is there in the exited state. So guys, whenever you will not put the prefix, it will just bring only the default containers. Okay, now guys, can I have more than one container for an image? So let's type this command here, docker run hello world. So what it will be doing, it will be printing again with another container. If I go here and type docker ps-a, you will see that I have now two containers are there. If I will remove this guy image, okay, I will directly ask docker daemon, okay, to run the image. Will this command be failed or not? Guys, if there is no image onto the machine, okay, then if I'll run the image directly, will this command be failed or not? For example, if I will delete the docker image, docker rmi hello world, this is being deleted. Okay, now if I'll run docker run hello world, will this be passed or failed? Okay, let's see guys. You can see here the command is not passed. If I see the logs, okay, so what it is doing is it is first going and searching the image locally. If it is not getting, then it is going to the Docker hub, it's downloading the image and running it. So it means it didn't fail. Okay guys, so the takeaway is we can directly run an image without pulling it. So my question is guys, then why pull is required? If directly I can go and get an image, why pull is required? Why I have two commands are there for the same reasons? So guys, is it a good idea to download an image in the production if image downloading is taking 10 minutes or 20 minutes of time? Sometimes images are bulky images. Is it a good idea to download an image and then start it, or better keep it downloaded version? So guys, always we have to reduce the latency. If sometime your network is not good, sometime your production needs quick fix. So in that situations, let's keep the image downloaded and then run it. Okay, so always when you download whenever it is required, it increases the time. So always we should reduce the time, because in DevOps time is money, time is everything. Okay, to save the time, always keep it ready. Whenever it is required, you start it. Now what we will do is guys, we will push an image to remote. So guys, there is a command is there called docker login. If you type this command, what it will be doing is it will allow you to log in into your Docker hub. Okay, so login succeeded, because in this machine probably I logged in before also. So if you type this command docker login, it will ask for your credentials and then it will allow you to log in into your Docker hub. Now what I'll be doing is, now if I'll do Docker images, we have this my hello world job there. Okay, so what I'll be doing is, let me rename it with my prefix, or let me create an image with my prefix docker. So guys, if you want to create a new image with the existing image, the command is docker tag hello world is my image which is already available. Now I am creating a new image with my own prefix. Okay, so if I'll type here docker images, you can see here You can see here Manoj 3004 hello world. Oh, sorry, I tagged wrong image. Docker tag hello world. Okay, Manoj 3004. Now I've given a different name, 13th August. So I will get a new image. Yeah, so now if I'll type here Docker images, then you will see here Manoj 3004 hello world 3rd August image has come. Now if I want to push this image to my repository, I can push it Docker push Manoj 3004 hello world and 13th of August. Okay, this will push my image to my remote repository. If I'll go to my remote repository, okay, and if I'll refresh here, you can see here the image which I pushed here, okay, is available here. So since this image has been pushed with Manoj 3004, whenever I want to push this image, I can mention the name. For example, if I will just remove this image name from the locally Docker RMI, if I remove this guy, okay, so this will be removed. Okay, but if I want to pull it, I can pull it Docker pull. Okay, this is pulled. Okay, so whichever image I want to pull it, I can pull it easily. Just I need to pass the prefix. So guys, that's all about the very basics of the Docker. Now quickly I will explain one more concept, Docker Hub. In an application, usually how many tiers would be there? Usually it will be a front end and a back end one, right guys? Right guys? So guys, in back end or front end, which has to be started first, back end or front end? A backend should be started first. So guys, whenever we start application, does it make sense to start backend and front end separately, or we should have a mechanism which should start both the applications together, but need to maintain the dependency, like first backend has to be started, then front end has to be started. It has to be started maintaining the dependencies or start them manually. Should be start automatically, right? So guys, Docker gives a utility called Docker Compose. So what Docker Compose says is it allows people to start both the guys together, a front end guy and back end guy. If you want to maintain the dependency, you can maintain the dependency that first my back end guy has to be started and then my front end guy has to be started. Okay, and you can manage to start them together. Okay, start them together, stop them together, remove together, okay, or maybe down together. I'll tell you what are the terms, these terms, okay, but this all can be possible using Docker Compose. Okay, so quickly I will explain you this concept. So guys, what happens is Docker Compose provides you a functionality, to start multiple containers together, okay, and to manage them together. For that you have to install Docker Compose utility, and apart from that you have to write your code into a Docker Compose YAML file. So Docker Compose understand this with the Docker Compose name, like docker-compose.yaml file. Okay, and whenever you mention multiple container detail like front end and back end, Docker Compose them as a application or a service. Okay, so in the form of service you have to write it, and then it actually let you allow to start them together. Okay, so you have to install this utility with this command, docker curl command. Okay, so it has downloaded one, it is giving you access to the certain files. Okay, now guys, we can go and create a file called touch docker compose.yaml file. Okay, and then we will go to this file pico docker compose.yaml file. Okay, oh, it's already there. 1 minute guys, let me create a folder. Okay, now let me touch a file docker. Okay, so I have a code is there. I can walk you through with this code. So first guys, we have to mention the version name. Okay, so version is nothing guys, everything in Docker is a REST API. So REST APIs are keep on changing. So version tells which REST APIs you have to call. Okay, so we are calling version 2. There is version 1 also, there is a version 3 also, but the most stable API version is version 2. As I told, each and every container application will be called as a services. So we have a DB services there, we have a WordPress services there. But as I told, dependency should be there. So WordPress should be dependent on DB. You can see the DB is starting first, but let's say by mistake WordPress also getting started first. So it will look, oh, there is a dependency is there, I should start DB first. So it has mentioned what is the image name, what are the different volumes are there. Whenever it change there, it should restart always. Some environment level parameters are there. Same thing for WordPress here. Okay, some depends image. So this is called port forwarding, which we do it for firewall opens, restart always, some environmental variables, and they're declaring the volumes also. So Control X, I'm saving this. This is being saved. Okay, so there is an issue. Let me restart the session. Okay, both the containers are started. If you want to stop the containers, you can stop them together. PS is the command which says what is the status of the container. If you want to stop them, you can stop them with this. Okay, stopping both the containers together. PS command, both the containers are stopped. If you want to run, you can start them together. You can see them, we are starting them together. Okay, if you want to remove them, you can stop them and then remove them. Okay, both the containers we are removing it. Okay, now if you want to start them together, you can up them, docker compose -up -g. This is starting both the containers together. But suppose guys you want to remove the containers also, and whenever containers get started, actually creates one network also. If you want to remove that network also, the command is docker compose down. It will offload all the footprints of the containers. Stopping containers, it will remove the containers, it will remove the, see, it has stopped the containers, it has removed the containers, it is removed the network also which was created. Okay, so in short guys, with the help of docker compose you can manage multiple containers together. So guys, if my containers are sitting in a different virtual machines, do you think this docker compose will work? No. So guys, if your containers are sitting in a different machines, then it's a matter of orchestration. And for orchestration purposes, guys, we have multiple concepts are there. Okay, so the orchestration is comes into the picture when you have containers are there in the different machine. For that, you have multiple things are there, multiple products are there. So multiple products are like we have Apache Mesos are there, which is kind of obsolete now. Swarms are there, okay, and Kubernetes are there. So guys, Swarms is a product which is given by Docker company only, but Swarms has some limitations. Swarm is not a kind of great product nowadays. So everyone is moving towards Kubernetes. So guys, that's all from my side. Thanks for joining.